Hello everyone, I am Brian Macon. Welcome back to the Math Fun Room. I'm super excited about this chapter where we learn about the conics, hyperbolas, parabolas, and ellipses, which have some really exciting applications. So let's get started. In this video in particular, we will begin learning about conics. The word conic is an abbreviation for conic sections, which are curves that are circles, ellipses, parabolas, and hyperbolas. In just a moment, we'll discuss how the conics are generated. There are a wide range of applications that involve conics. A parabola is used in engineering of satellite dishes. Ellipses are used to model the orbit of our planets around the sun. And hyperbolas are used in acoustics and the construction of reflective mirrors for telescopes. These are just a few examples of the many applications of conics. Now, before we learn about these applications, we first need to discuss the foundation of the conics and how they are defined. The word conic comes from the word cone, which is a geometric figure. We all know what an ice cream cone is, as shown on the left of this slide, which is really called a right circular cone, because the base of the cone is circular and the central axis of the cone is at a right angle to the circular base. Now, in order to geometrically construct a cone, we complete the following. Let A and G be two distinct lines that intersect at a point V. We keep the line A fixed. Now rotate line G about line A while maintaining the same angle between lines A and G. Now, the collection of points swept out or generated by line G is called a right circular cone, as shown in the figure on the right-hand side of this slide. The fixed line A is called the axis of the cone. The point V is its vertex, and the lines that pass through G and lie completely on the surface of the cone are called generators. We can think of these as quote-unquote snapshots of the line G as it is rotated around line A. Now, the cone consists of two parts called napes that connect at the vertex. Another way to think of it is two napes is each of two ice cream cones touching at their tips with the central axes lined up. Now that we have defined how the cone is generated, let's consider how to generate each of the conics. And the conic sections are curves that result from the intersection of a right circular cone and a plane. We discuss only conics formed where the plane does not contain the vertex. These conics are circles when the plane is perpendicular to the axis of the cone and intersects each generator, as shown in figure A on this slide. An ellipse, as shown in figure B, is created when the plane is tilted slightly so that it intersects each generator but intersects only one nape of the cone. Parabolas, as shown in figure C, are generated when the plane is tilted further so that it is parallel to one and only one generator and intersects only one nape of the cone. And finally, figure D shows that a hyperbola is created when the plane intersects both napes. If the plane contains the vertex, the intersection of the plane and the cone is a point, a line, or a pair of intersecting lines, and these are called degenerate conics.